Hello children, welcome to AIMS India's online classes. In today's video, from physics subject, force and laws of motion topic we are going to continue. So in our previous video, we have discussed some problems children. Up to 9 problems already we have completed. Let's start with next problem, 10th problem. Here the question is, a force acts on a body of mass 200 grams. The velocity of the body changes from 15 meter per second to 25 meter per second in 2.5 seconds. What is the magnitude of force, assuming the force to be constant? The velocity of a body changes from 15 meter per second to 25 meter per second in 2.5 seconds time. So if the force is constant, what is that force that we have to calculate? We have the formula F equal to ma. The formula for calculating force is F equal to ma, where acceleration again can be written as v minus u by t, rate of change of velocity, m into v minus u by t, that equal to, in the place of mass, we can keep 200 grams means 200 by 1000. If we divide by 1000, it converts into kgs, which is equal to 0.2 kg. So in the place of mass, we can keep 0.2 kg. V, final velocity, because the velocity changed from 15 to 25, 15 is considered as initial velocity, 25 meter per second is considered as final velocity. So in the place of v, 25 we will keep, in the place of u, 15 we will keep, by time, 2.5, by 2.5. So 25 minus 15 equals to 10, 10 by 2.5, 10 by 2.5, 10 by 2.5, or we can remove point, we can keep 1 0 upwards, or if you multiply by 10, multiply with 10, both numerator and denominator, 10 into 10, 100, 2.5 into 10, 25, 25 4 times 100. So we will get 4 here. 4 into 0.2 is nothing but 0.8 newtons. So answer, option D, 0.8 newtons is the correct answer. Next, 11th question. A force of 0.6 newtons acting on a particle increases its velocity from 5 meter per second to 6 meter per second in 2 seconds. What is the mass of the particle? A force of 0.6 newtons, it acts on a particle, it increases its velocity from 5 meter per second to 6 meter per second in 2 seconds time. What is the mass of the particle? So we have force formula F equal to ma, m into, in the place of a, we can keep v minus u by t, in the place of m, we can keep 0.6, v minus u means 6 minus 5 by 2, 0.6 into 1 by 2, 6 minus 5 means 1. Here v minus u by 2, 6 minus 5 by 2 means actually here, okay, F equal to, we are getting 0.6 into 6 minus 5 means 1 by 2, 1 by 2. Sorry children, here not mass, erase this step. Here the value of force is, 0.6, 0.6 newtons equal to m, mass of the particle we have to find, velocity of the particle 6 minus 5 by 2, or 0.6 equal to m into 1 by 2, m into 1 by 2, or m equal to 1 by 2 will come this side, it will become 2 by 1, it will become 2 by 1. m equal to 0.6 into 2 by 1. 0.6 into 2 is nothing but 1.2 kg. So 1.2 kg, option A is the correct answer. Option A is the correct answer. Next, 12th question. A force acting on a particle of mass 200 grams displaces it through 400 centimeter in 2 seconds. Force is acting on a particle, on which particle which is having mass 200 grams and displaces it through 400 centimeter in how much time? 2 seconds. Now find the magnitude of force. Now we have to find force. If the initial velocity of the particle is 0, u value is 0. If the initial velocity is 0, then we have to find the force acting on the particle. Because here the force, they have given the initial velocity. So we have to find the, here what they have given, mass they have given, displacement they have given, time they have given, and initial velocity they have given. Force we have to find. But the formula of force is mass into acceleration. We have mass, but there is no acceleration. For finding acceleration, using this STU quantities, we can make use of the formula S equal to ut plus half at square, and with this we have to find A value first. After finding A, using the formula F equal to ma, we can find the force. So first we have to find the acceleration. For that, let's take the formula S equal to ut plus half at square, where S how much? Where S equal to 400 centimeter. Where S equal to 400 centimeter. 400 centimeter. Or if we convert into meter, so 1 meter equal to 100 centimeter, or 100 centimeter equal to 1 meter, then 400 centimeter equal to 4 meters. 400 centimeters equal to 4 meters. So here this equation we can take it as, in the place of S, we can take 4 meter equal to initial velocity 0 into time 2 seconds, 0 into 2 plus half into A value we don't know, into t square, 2 square. You can strike off this, children. Let's see this formula. Now 4 equal to 0 into 2, 0, plus half into 1 by 2 into A into 2 square is 4. 2 square is 4. 4 gets cancelled. 2 will come here. A equal to 2. So we will get A equal to 2 meter per second square. A equal to 2 meter per second square. Now what is the formula for force? Force formula F equal to ma. Means where mass is 200 grams. 200 grams means if we divide by 1000, it will become 0.2 kg. So ma means 0.2 into acceleration value 2. 0.2 into 2 is nothing but 0.4 newtons. So the force acting on the particle is 0.4 newtons. Next children. 13th question. A body of mass 300 grams at rest breaks into 2 parts due to internal forces. One part of mass 200 grams is found to move at a velocity of 12 meter per second towards east. Find the velocity of other part. If one part of mass 200 grams if it moves with 12 meter per second velocity towards east, what will be the velocity of other part? Out of 300 grams mass, if one part mass is 200 grams, then other part mass will be 100 grams. Other part mass will be 100 grams. So here, children, a body of mass 300 grams breaks into two parts. Why it is breaking into two parts? Because of internal forces. Out of two parts, one part mass is different, other part mass is different. Masses are different. And one part velocity is 12 meters per second, direction is towards east, other part velocity and direction we have to find. For this, we have a law called Law of Conservation of Linear Momentum. Law of Conservation of Linear Momentum. According to that, before collision, total momentum, before breaking into two parts, total momentum equals to after breaking into two parts. The total momentum before this explosion will be same. Before this explosion will be same to after the explosion. So before breaking into two parts, actually it is under rest. Momentum is product of mass and velocity. Before breaking, it is under rest position. So that's why total momentum will be 0, because there is no velocity before breaking of the mass. So 0 equal to m1 b1, mass and velocity product of first particle, mass and velocity product of second particle. This after the breaking, whatever total momentum is there, it will be equal to 0. So, but after breaking into two parts, one part mass is 200 grams, which is nothing but 0.2 kg, and velocity is 12 meters per second. 12. Other part mass will be 100 grams, because out of 300 grams, 200 grams one part means other part will be 100 grams or 0.1 kg. Its velocity we have to find, let it be v2. We will get this equation by this law of conservation of linear momentum. So 0.2 into 12, 0.2 into 12, 0.2 into 12 equals to 2.4, and one direction. Suppose east direction. If we take it as negative, this whatever velocity is there, if we take it as negative direction, then other particle, if one particle moves towards east, other particle will move in opposite direction towards west. If east direction we take it as a negative, west direction will be positive. Okay. So R, if we take east direction as positive, then west direction will be negative. First, let's find the value. 0.2 into 12, 24, plus 0.1 into V2. 0.1 into V2. 0.2 into 12, actually 24 means we have to keep a point there. 2.4 plus 0.1 into V2. 0.1 into V2 equal to 0. Is there. Or if you want to find V2, this 2.4 will go that side. V2 equal to 2.4. If it go towards right hand side, it will become minus 2.4 by 0.1. Point to point cancel. V2 equal to 24 by 1, which is equal to 24. Minus 24. So V2 value we are getting minus 24 meter per second, which indicates, because the first particle velocity is positive, the second particle velocity is negative, means it is in opposite direction to the movement of first particle. The first particle is moving towards east, so this final particle is moving towards west. So we can remove minus and we have to tell 24 meter per second towards west. So option A is correct, children. Actually, here when we mention minus here, we should not mention the word west. If there is no minus, we have to mention the word towards west. So option A is correct, children. Next, children, question number 14. A mass of 2 kg at rest travels for 4 seconds with an acceleration of 1.5 meter per second square. Find the gain of momentum of the body in that 4 seconds. So we have a mass of 2 kg which is at rest. It travels for 4 seconds with an acceleration of 1.5 meter per second square. Before the moment, it is at rest. So initial momentum will be 0. But after 4 seconds, after moving with some acceleration, it will gain some momentum. That momentum we have to find out. So mass 2 kg, initial velocity 0, time 4 seconds, acceleration 1.5 meter per second square. Then we have formula for final velocity, v equal to u plus at, 0 plus 1.5 into 4, 6 meter per second. This is the final velocity. So gain in momentum means final momentum minus initial momentum, mv minus mu. But here m is constant, m into v minus u we can write, where mass is 2 kg, v is 6, u is 0. So 2 into 6 minus 0, 2 into 6 equal to 12. 12 kg meter per second. The unit of momentum is kg meter per second. So there is a gain of 12 kg meter per second in the momentum of the body. Next one, 15th question. Due to an impulse, the change in momentum of a body is 1.8 kg meter per second. If the duration of impulse is 0.2 seconds, what is the force produced in it? What is the force produced in it? So impulse equal to change in momentum of the body. Change in momentum of the body. So impulsive force, we can denote it with the F symbol. Impulsive force equal to I by T. So where? So I means here change in momentum, which is 1.8 kg meter per second, by time. In how much time it happened? So here I means change in momentum. Change in momentum means which is nothing but impulse. It is denoted by the symbol I, and I by T, impulse by time, or rate of change of momentum is called force. We have defined force as rate of change of momentum, means change of momentum which is I, which is impulse, by time. Here change of momentum is 1.8, by time is 0.2 seconds, point cancel, 18 by 2, which is equal to 9 newtons, So the impulsive force produced in the body is 9 newtons. Next, 16th question. Which of the following are vector quantities? Vector quantities means the physical quantities which have both magnitude and direction are called vectors or vector quantities. So force is a vector quantity because it depends on acceleration. Force formula ma, which depends on acceleration, which is a vector. So next, velocity also a vector. Momentum formula Mass into velocity depends on velocity, which is a vector. Momentum also a vector. So answer all the above. All are the correct answers. So D option. All are vectors. Next one, 17th question. Two bodies collide at the same temperature. Which of the following is conserved? Which of the following is conserved? Which of the following is conserved means two bodies collide. If two bodies touch with each other, their velocities will change. Their velocities will change. So velocities cannot be conserved. But momentum, total momentum before collision, total momentum after collision will be same. Momentum is conserved. So not only momentum, total kinetic energy before collision, total kinetic energy after collision. Kinetic energy means half mv square. So half m. Suppose if the velocities are initial velocities are u1, u2, final velocities are v1, v2, then half m1 u1 square plus half m2 u2 square. So this is the total kinetic energy before collision equal to half m1 v1 square plus half m2 v2 square. Total kinetic energy after collision. So this kinetic energy also will be conserved. So both 2 and 3. So option B. Only 2 and 3 are conserved. Next one, 18th question. Vehicles are provided with shock absorbers. Which of the following laws of Newton given below explain this? So why they are provided with shock absorbers means, so Newton's second law, what it will state? So rate of change of momentum of a body, rate of change of momentum is P2 minus P1, change of momentum by time or impulse by time. This rate of change of momentum is directly proportional to force applied. So that's why to avoid damage due to this jerks of the bike, the vehicle, to withstand that force, whatever force produced during the sudden brake or during the road, if road is uneven, then there will be some impulsive force created in the vehicle because of that change of momentum. To avoid that, to protect from that impulsive force, the vehicle is provided with shock absorber, and it is based on Newton's second law of motion. So answer option B is correct. Next one. So 19th question. On what principle does a jet engine work? So jet engine works on law of conservation of linear momentum. So answer option A is correct. So the jet plane will go up. And the smoke will come down. So here total momentum before the starting of jet plane and after the starting of jet plane will be equal. And it also works on Newton's third law of motion. So answer option A is correct. Next, 20th question. A ball of mass 100 grams is moving with a velocity of 10 meters per second. The force of the blow by the bat means the bat is hitting the ball for 0.01 seconds. Means during this time, the ball is contact with the bat, or the force of blow by the bat is given to the ball during this time. Then what is the force exerted on the ball by the bat? So here mass of ball 100 grams means 0.1 kg. Velocity of the ball 10 meter per second. Before hitting the bat, its initial momentum is mass into velocity 0.1 into 10, 1 kg meter per second. After hitting the bat, the ball changes its direction, reverses its direction, its velocity gets reversed, it comes and hit in this direction, it goes back in the opposite direction. So its velocity will be minus 10 meter per second. Now its momentum will be 0.1 into minus 10, 0.1 into minus 10, minus 1 kg meter per second. So F, force. How can we calculate force? Means change of momentum by time or rate of change of momentum. So m2 by m1 by t. Final momentum is minus 1. Initial momentum is 1. Minus 1 by time 0.01 seconds. That equal to minus 2 by 0.01. We can point after 2 decimals are there. We can keep 2 zeros in the numerator. We can remove point here. So minus 200 newtons is the force exerted on the ball by the bat. That's all for today, children. So remaining we can explain in our next video. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. You can also visit our website www.aimstoday.in for information regarding online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.